Alright, today we're going to talk about 8.7, factoring difference of perfect squares. Now this is a specific pattern that you're going to hopefully become pretty used to. It's a pretty common pattern in factoring. Now before we even do that though, we want to talk about what is a perfect square. Now number-wise, I think most of us know what that is. Examples of a perfect square would be numbers like 1, 4, 9, 16, etc., etc. Remember, those are numbers that have even square roots. They have numbers that have a factor that you can multiply by itself to get back to this number. So those are perfect squares. What are all other perfect squares? Well, variables can be perfect squares too. A perfect square variable would be something like x squared, or y to the fourth, or even something like w to the sixth. And what you'll notice is that for a variable to be a perfect square, it has an even exponent. So like x to the third would not be a perfect square. Now, the pattern we're going to talk about today is called the difference of perfect squares, or sometimes people just shorten it to the difference of squares, or difference of two squares. And the pattern works like this. It says that if you have a squared minus b squared, that factors to be a plus b times a minus b. Sounds pretty simple, and probably the easiest way to really understand it is to just do some examples. So let's do some. So let's x squared minus 4. Okay, we want to factor this. Now, one of the best ways to understand this pattern is to actually understand the name of it. It says the name difference of perfect squares. Difference meaning minus, so that means we'll always have a minus sign here. And perfect squares meaning that this term has to be a perfect square, and so does this. So is x squared a perfect square? Yes. Is 4 a perfect square? Yes. Is this subtraction? Yes. Alright, so that means it fits the pattern. So, the way we factor it is this. It says a squared minus b squared equals a plus b, a minus b. So when I write that, that is saying that it's the square root of a squared. So, the square root of x squared is x. Okay, plus the square root of b squared, or the square root of 4 is 2. And then we do the exact same thing, but it's subtract. And that's it. Now, how do I know for sure that that really is it? Well, you could go through and distribute. You could multiply x times x to get x squared. X times negative 2x is negative 2x. 2 times x is 2x. 2 times negative 2 is negative 4. And if you simplify, you get x squared. These cancel, minus 4. So we're back to the original. So that really are the factors of x squared minus 4. And that's it. There's nothing more complicated than that. So let's try a couple others to see if you're really understanding what I am talking about. Let's do one more easy one. Let's say it's y squared minus 16. So I'm going to start out double checking perfect square, subtract. Alright, so I can do it. So the square root of y squared is y, plus the square root of 16 is 4, and then the square root of y squared is y minus the square root of 16 is 4. And there you go. Okay, so what if we add a little bit more interest to the problem? Say 4x squared minus 1. Alright, if you want to give that one a shot, just hit pause, give it a shot, and then hit play again and see if you get the right answer. So let's try it. I'm going to write this out. Now again, always check. Minus, yes. Perfect square, yes. Perfect square, 1 is a perfect square because 1 times 1 is 1. So, square root of 4x squared is 2x plus square root of 1 is 1. And then this would be 2x minus 1. Done. What about this one? What about 9x squared minus 121? Okay, again, hit pause, give it a shot, and then come back and see if you got it right. Hopefully you got this. 3x plus 11, 3x minus 11. Alright, hopefully you're starting to get the gist of this. I got two more examples I would like to try. Let's try number 5. how about x squared plus 36? Okay. Hit pause, give it a shot. All right, let's see what you got. Hopefully, you wrote this. It's not factorable. All right, hopefully you didn't write x plus 6, or anything crazy like that. Why? Because of this. It says plus. Remember, the pattern says difference. So if it is plus like that, then that doesn't qualify for this pattern. Can't factor it. So you just write not factorable. So tricked you a little bit right there, but hopefully you remember that part. Last one. Let's try one that's a little tougher than the others. What if I had 4x squared minus 9y squared? Well, it says minus, so that's good. The first part, 4x squared, that's a perfect square. 9y squared is a perfect square too. So if I factor it, the factors of 4x squared, or the square root of that, pardon me, is 2x plus square root of this is 3y, and then 2x minus 3y, and I'm done. And that's the basics behind difference of two squares. So hopefully that's a pattern that you'll be able to recognize from now on, and hopefully it was one of the easier ones that we've done so far. All right, hopefully that worked. If not, ask some questions or write some questions down, and when you come to class tomorrow, hopefully you'll be able to get those questions answered. All right, thank you.